All right, let's get into some components here. So, have you guys been in a big boiler room? It's got all sorts of stuff in it. Okay, did you ever confuse the heck out of you? You think like, what the heck, right? The first time you walked into a boiler room, you were like, what? How am I supposed to touch this, right? Okay, there's a lot of things that go into radiant, and it scares a lot of guys. It scares a lot of people. They think it's just complicated. They think it's way too much stuff. So it has scared some people away. Obviously, you guys are here, so you're not too scared. It's great, right? Learned something. But there's a lot of stuff that goes into it. There's a few rules that you got to follow, but other than that, it's really simple. Okay, it's really basic, and hopefully we'll help you guys learn that and understand it. So as you guys get out there and start doing more of it, you'll be able to do it confidently and be able to do this stuff. Okay, so PEX tubing, a lot of different PEX tubing out there, right? A lot of different brands. Let's see, you ever heard of Viga, Uponor, Watts, Mr. PEX,
Pert
Pipe, Ross,
Rayhow.
My heavens, who else have we got? Okay, you ever heard of any of these companies? Right, they're all over. Okay, every wholesaler's got a different line, and they're going to say they're the best, and they're the best. PEX tubing, Specs tubing, they're all very similar. Okay, you're going to learn that there's four types of PEX. PEX A, B,
C.
3, yeah. A, B, and C, and PERT. So I guess, yeah, technically 4. Okay, they're just manufactured differently. That's the real reason for those. Okay,
They're all Osterberry.
yes and no. That's because they make both of them.
Yep.
Okay, so as we're doing radiant systems, do we do regular potable PEX that you're going to put in a plumbing system, or do you need to get a special PEX? Special PEX that has a barrier layer in it, okay? And all that barrier layer is doing is just keeping the oxygen from being able to get into that PEX tubing, get into your water, which is going to create havoc in your system, okay? And we'll get into that as we go through the classes so you understand it better, okay? What about this blue-green pipe? Anybody ever seen that stuff? Okay, Aquatherm, it's a fusion pipe. Anybody played with it yet?
I have, I do more.
Okay.
Commercial stuff, so.
Okay. Commercial does use it a lot. Okay. You love it?
No.
Exactly. I like that. Thank you.
Well, no, it only has, it had a certain temperature you can all put in there. You can't put 160, 180 over Egypt.
Okay. Yeah. Depending on what's it called? They make different spec.
We can chat with Aquaferry, I think.
Yeah. They make different. What the heck is the term I'm looking for?
Like oxygen.
Different grades or whatever. Yeah, there's
Colors and stuff, so they make them for issues.
Yeah, because they do have.
Well, I use IPD or something.
Yeah, there's so many different terms.
Yeah,
I don't know all of them. Yeah,
But it's so labor intensive that I think a lot of contractors are getting away and just go copper because it's just, honestly, at the end of the day, I think it's probably the same price.
Right. Yeah. It's cheap pipe and cheap fittings, but the labor and the time it takes you to do it is where you lose.
That's hot ass. Yeah, and bowls.
Yeah. So you basically weld this pipe together if you've never done it before. Okay, so you have a hot iron that you heat up to 400 to 500 degrees, and then there's crazy procedures you're supposed to follow, right? You got to clean the pipe, you got to make sure it's cut straight, you got to do whatever. Then you're supposed to have what they call a spider, which is a clamp that holds your fitting in the pipe, and then it puts it together, puts it on the iron for a certain time period depending on the size of the pipe. Then you pull the iron, or you pull the spider out, pull the iron out, put it back together, then you got to hold it for another specific time period and wait for it to cool and to final fuse together. Then you can take everything apart, and then you can start the next fitting. Okay? So it's like a 10-minute process to get one fitting together. Okay, so that's where you're losing money and time, is because it takes so much time to do it, right?
Unless your copper gets stolen off the job, and then you got to reinstall it again.
Right.
So that's the gamble.
A lot.
Which happens
We
a
do
lot.
it all the time, but it's such a pain in the butt. So the nice thing about it is like say a 2-inch pipe size of this, you can get a lot more flow through than you can with a 2-inch piece of PEX pipe. Okay, so that's the other benefit of this, is it has better flow characteristics to it. So you can actually do a smaller pipe than you would if you went to PEX pipe. Okay, so you generally, this in 2-inch, you would be going 3-inch in PEX. Okay, who wants to play with 3-inch PEX? Okay.
Those are the house departments.
Okay, we do it, but again, it's labor intensive, right?
Yeah, yeah.
Okay, because the only manufacturer I'm aware of is Upanor, and if you're familiar with Upanor, they like to do the expanding fittings, right? You got to have a special tool, it's got to expand that pipe, then you can get the fitting in there, right? But when it's 0 degrees outside, who in the crap wants to play with that? Okay, so it's cold, then it doesn't work, then you got to wait for it to get back, and you got to shrink it, you got to heat it. So there's benefits to everybody, and okay, we're just trying to point out different options. Okay, we want to get you guys familiar with everything that's out there. So when you come across it, you see it, hopefully you'll know what it is, you'll have an idea what it is and what you got to do to use that type of stuff, okay? So who's currently installing radiant systems? Okay, a couple of you. Okay, are you guys familiar with the manifolds? You ever seen any of these manifolds?
Or about it.
Worst part about it. Okay, what do you don't
Explain,
like?
yeah.
Always cramming it in tight stuff, and stupid places where they shouldn't be.
Okay. Tight areas, hard to fit in everywhere. Okay.
Big ones like, you know, the plus ports, they be kind of hard to get all your packs per, like have them all fit up.
Okay. Okay.
Yes, I think.
Okay. Yeah. Yeah, because it is the final product, so you're trying to make it look good, right? Oh, I got some pictures to share. I had to yell at some guys the other day, and yeah, they didn't do a very good job at putting manifolds together. So, okay. Again, manifolds, they're great. Some guys, Eric used to do what back in the day?
I used to cut PEX and build the manifold out of PEX, and I hated that. I hated that. And
Now, can you do that? Is there anything wrong with doing that? PEX tees, crimp tees, and 90s, build your own?
We build them out coppered sometimes.
Okay.
That's just strip the experience 0 pound doing.
well, you're also potential leak paths because you're doing all those crimp fittings, but also we're dealing with obstruction of flow. You got all that, in there as well.
Okay.
There's a lot of
So,
labor intensive too, building them.
you guys are going to get to see how good I am at drawing.
Sorry, I'm not happy.
All
It
right.
was not fun. Did not like it.
Let's go over this for a second. Okay, so we got a bedroom. We need to heat that bedroom, right? And let's say that this bedroom is going to get 2 loops. So we're going to put our manifold in here. So you're going to come out your manifold. You're going to run your loops. Losing my marker. And you're going to run this one. Holy crap, that's bad.
Yeah, that's
Okay. So you're going to put 2 loops in here. The problem is you sent your new guy. So instead of spacing it evenly, he took that full 300-foot loop of this one, and he ended up using that entire 300-foot loop. So he went like this, came back, and then he's like, oh, well, now I only need that much to do the second loop. If you only use T's and PEX fittings to make your manifold, what's going to happen with that bedroom?
But it's get hot, just pulling up.
Which one?
The small one get out of that.
Okay, the small one, because water wants to go where?
First back path of the
Shortest path, wherever is easiest.
That's half of the bill. See if, I can say it's going to take that.
Okay, right. Now,
yeah.
so what would be the benefit of spending the money and putting one of these type of manifolds in instead of just making your own?
You can use balance on ribs.
Okay,
That's exactly right.
that?
If you use just,
Okay,
Yep.
you can adjust and balance it. Okay,
you do that with that and shove about too.
Yeah,
Right, yes,
it takes
yes.
a minute though. That's a
right? Who wants to go with the old plumber way, right? You got your pipes coming up and you're going to do this. You'd be like, all right, it's a little water, okay, and then you're gonna take your ball valve and you're gonna tweak it just a little bit, right? Who's done that? Come on, right?
It's hard, really hard on the bigger systems too, where
Oh, it's pain in the butt.
see, and then you're
Right.
kind of see the flow so you can kind of adjust them quickly.
Right. Yeah.
I'm sure smaller.
Still.
Yeah.
Okay. This is just one of those items that is very beneficial to try and spend a little bit extra money to get something like this. Okay. There's nothing wrong with making your own manifold. If you want to make it out of copper, all of my snow melt manifolds, I'd make them out of copper. Okay. We don't do this. We're going to talk about why you don't usually put these on a snow melt system. Okay. I do sometimes, but not most of the time. Okay. And it's due to GPM flow rates, right? But if you want to make your own, that's fantastic. That's fine. That's great. What do we need to do in the room then when we lay the tubing?
Make sure it's even lengths.
Okay, you need even lengths on your footages, right? Okay, so if you got a room that needs 2 loops and both loops are 200 feet, make sure you go the 200 feet, okay? So it's just the rule of thumb on that, right? But if you go into a system and it's a remodel, you didn't do the basement, do you want to put your own in, or do you think we should spend the money, talk to the homeowners, and say, look, let's spend a little bit more money.
It's worth it.
Let's put some better parts in,
Trust
right?
me. It's worth
Okay.
it.
Because then on here, like especially the silver one that you're looking at, it gives you flow meters so you know what flow you're getting through. Then you spin that flow meter, you can adjust them and turn them up and down. You get everybody doing the same flow. All right, now I'm going to get even space heating across my whole room, right? Okay. Make a little sense? Okay, so these are just some things. We want to point some of this out because this will make a big deal in your system. Okay, if you don't balance your system, you're going to get people complaining. You're going to get homeowners mad at you. Now we got problems, right? Okay, so we want to save you money. We want to help you guys make money, but don't hurt yourselves by going cheap, and then in the end, you're spending too much money because now you got to go figure everything out. Okay. If you want to buy the red PEX versus the black or the orange or the white, I don't care, right? PEX is PEX, okay? I have my preferences. I have who I like over the years, okay?
But I mean, just out of curiosity, is like obviously I'm primarily a plumber, just kind of getting into radiant.
Okay?
But like tubing, like I mean, like you're saying, it's like wildly different. Like, is there a
little bit
to keep in mind? Well, I mean, every house is going to have like a different color type or whatever. Is there anything you got to keep in mind when you're like transitioning, like making a repair, and they're like pretty much all like universal?
Yes, they are universal. Your benefit is if you know which PEX tubing you're playing with, the repair fitting, I would stay with that manufacturer's repair fitting just for the warranty purpose, especially if it's a new construction, right? So new construction, you laid everything in the floor, the framers come in and they drill an anchor, go right through your tube, right? Happens every job, okay? You got to break that up, you got to fix that. If you stay with that specific manufacturer's repair coupling, you generally will keep their warranty, okay? If you use somebody else's, you do a crimp fitting instead of a press fitting,
Or expansion.
and something happens and you need a warranty, they may come at you and say, all right,
We do have specific, well, I guess that was my main, but they do have specific transition couplings, like
yes,
Yep.
different.
yeah. Everybody's got their way of doing it. Yeah. And that's what we want to show. So we got reps coming in throughout the next 5 weeks, and that's what I want them to bring in and show you is their product and what their fittings are and what they deem as their benefit from their product, right? Okay. Everybody heard the 1960 fittings or the F1960? Okay, there's all these different terms.
F1807, F19.
Yeah, 18, it's just the crimp or the fitting style of how it's put together. Okay, so Uponor does the expansion fittings. Viga does the PEX press fittings, or we're probably all familiar with ProPress, Mega Press, right? Viga has that whole press type system. So their PEX fittings are a crimp press fitting. Okay, then we can go, plumbers love to do just the copper rings and the hand crimp fitting, right? Okay, pretty standard, Home Depot, everybody's got it, right? Uponor, Rayhow both have an expansion type fitting. You have to physically expand the pipe, put the fitting in, and then it shrinks back down onto that fitting. Okay, so different style. So everybody's got their different style. They all have their different claims of we're better than them because of whatever, right? They all work the same. It's just preference of what you end up finding you like to do and what is available at your wholesaler that you...
Like, it's just crude, like, because I do more like just service and repair, so I guess it's just not, but you said it'd be pretty well.
Yeah. Well, so if you're just doing a lot of service and repair, then you're just going to find what works for you and just use it.
Well, I mean, just branch out, I guess, a lot of like, homeowners doing like weird things and.
That never happens. What are you talking about?
Right. For anything.
Yeah.
So if you find like black irrigating and, not sold and you are like, he's ready to go find like the rest tool.
So, yes, because there are some manufacturers that are no longer around.
Yes.
And they don't fit the fittings that we have. So there are going to be some instances where you're running around finding fittings.
Specs and like all my year as a plumbing, I like never, we count, I'm like, what do you mean 5/8? And it's like,
Right.
it looks like half and half.
Yeah.
No, it's just,
Doesn't quite fit. Yeah.
Yep.
sorry, what in line stuff or anything like that.
I did quite a while ago, but that's been a long time.
Been a long time.
I know last doses.
Yeah.
I get like a days of it.
Uponor had it for quite a while. Multi-core, I think was the name. Watts had something.
Yeah, but great.
Yeah, Watts had it. That was a big.
Yeah. I installed quite a bit of it. Yeah. And that was a pain in the butt too, because those fittings on those ones, you had to shave half of the pipe off and then put the fitting in and then crimp it and it's
Stand house somewhere like that.
a little bit. Yeah, you had to pull the shave. Yeah, it was an outer level layers.
Layers of it.
Yeah.
Yep. Yeah.
But it was cool when you were able to just bend it and it would stay. It was awesome. It was nice.
Yeah.
I guess.
You're working on the older system, but it is like a pipe stuff like that. So like basically your only repair options are going to be to like replace your concrete, like a fixed snow melt system, and some like old
No.
still make like
Yeah.
still make
There's still transfer type fittings. Yeah.
West. Yeah, this house bad to get it out.
Yeah.
Yeah, correct.
Yeah. So and that's where hopefully with the reps that are coming in, you get to know them. So like you said, the 5/8. The best rep in town for 5/8 fittings is Lundquist Cells, but it's a crimp fitting, so you got to have a 5/8 tool to do it. But
It's and I was like, that's
okay, and Uponor does 5/8. I used to do 5/8 all the time for snow melt, because one, it was easier to use because it wasn't 3/4, and so it wasn't as big and as hard to bend and move, right? So we did tons of it. But we were using the fittings that were specific for the unit and just went right to a 5/8 fitting. Okay, so we weren't worrying about 90s and that kind of stuff. But Uponor does make a coupling in 5/8, but now you got to have the expander tool and the rings and like the stuff.
something really made like out of his house and all good.
Yeah. Yep. Yeah. So I still do some 5/8 today. If you're doing snow melt for stairs, 5/8 is the best way to go. Do you do 3/4 on stairs? That's a pain in the butt. Okay, so if you do it right, okay, don't just go up and down stairs. So we'll talk about that as we go and the reasons why for that, because everybody does it. Okay. All right. So hydronic systems. Okay, as we're going to go over in these next couple of slides, there's a lot of stuff that you want to consider and you need to know. Okay, like I said, there's all this material that you guys are going to be putting in and playing with. But there's just a few rules of thumb that you need to know to make that system work properly.
Hey, James, real quickly, back onto the tubing before we go to the next slide. The cheapest part of the whole hydronic system is the tubing. What's going to be locked in the longest on that hydronic system? It's the tubing because it's encased in concrete. So when you're talking to a homeowner, a customer, let them know if they're on the fence on a hydronic snow melt or radiant system, talk them into at least getting the tubing in. Because once they pour the concrete, I've had a lot of buyer's remorse where the homeowners come in and go, oh, I should have put the tubing in. Well, you're done. You really are done unless you want to rip that concrete out and start all over. So put the tubing in, get it in the ground, and if they decide later on, you can build off of that. But Yeah.
Job of stapler.
No, we'll get into that.
And we're going to talk about some of that here in just a second too. Let's use that sort of. I can't remember if that was this one or next one.
It's in it's a couple slides, yeah.
Okay. Yeah, we'll show you some of the install types. Okay. More components. Let's see here. It's funny that I got all this
I noticed.
website. Those of you that are currently doing installation systems, there's a huge price increase coming from these guys, FYI. So if you got bids out there, you might want to double check your bids with your wholesaler guys because, it's not just a little. Okay, FYI. Pumps, air separators, zone valves, dirt separators, zone valves. Who knows what these guys are? You might know those. Okay, zone actuator or thermal actuators, and what you refer to. Okay, so
Do you guys know what those are? When he's talking about zone actuators, where they actually mount? Go back on the back.
That's only how we use those fancy manifolds.
Yes.
We have one supply and one return switch. That's that area of the house. Then we can run multiple thermostat wires to those and it'll zone out.
Yes.
okay,
So say here's your manifold and you got 3 right there. That zone actuator would go mount right here on the top. You can run your thermostat wire to them. So that's where just for those that haven't dabbled in the hydronics.
and so this would go back to zoning, multi-zoning, right? So you can run this bedroom, you can run the bathroom, and then you could run the family room and just do one manifold, run all of your tubing to that manifold. You throw all these little actuator guys on it and zone each room, but you only have one pump and one set of main runs going to it. Does that make sense? Following? Everybody good?
Very hello.
What? Sorry. Oh, right. Yeah. You reduce the amount of pumps you're going to have on that system, right?
You return 1 inch, 1.8, 1.25 inch.
Yeah.
For 5, then 10, 12.
Right. Yep.
Or that. Yeah.
Right.
Do it that way. Don't necessarily really want to do it on new construction. You really want to supply care to every.
Okay. Okay. And that, so, okay. So this is great. I love it. So you would rather run multiple manifolds throughout the house and run separate pumps and main runs. Okay. Who would not? I run it different. Okay. I like that depending on the layout of the house, depending on the house, the size. Okay. But can we run one set of mains, have a manifold here, and one pump? You do it that way. Okay. Or do you like to do zone pumps or zone valves?
Pumps.
You do zone pumps. Okay. Can we do one pump and zone valves?
Mm-hmm.
Okay. I'm just bringing up a point that we have so many options to do. You guys find what you like. Make sure you're staying within the parameters that we're going to go over these classes, and make sure it works for you to the best benefit of your client. Okay. So I love it. It's great because I used to do it that way all the time. Okay. Changed over the years. I've learned a few things like, maybe I'll try this out. Okay. The company I currently work for right now, really big in just doing one pump, running one set of mains, branching off, and hitting multiple manifolds out in the house. Okay. Depending on the size of the house. Because we have some where, we'll run a whole bunch of mains from the mechanical room and do that.
Average 10 houses square.
Right. Yeah. Yeah. Okay. And even so, we're working on one right now that is probably 18,000 square feet. We have a pump board that has one pump and it only has 2 branches coming off of it to 2 separate mains. So during sub-rough, we ran, the picture's gone, the aquatherm, the green pipe, pain in the We ran a whole bunch of that underground. We branched off of it and hit a whole bunch of manifolds and made some stubs. So when they did the framing phase, we came in for rough, ran other branches off and hit the next level of the house, and hit a whole bunch of manifolds. And then we just did manifolds with all the little zone actuators, and that's how we zone it, okay? But with that, we had to go to pretty spendy pump that will self-regulate itself off of the pressure of the system that pump sees, and it will either speed up or slow down depending on what the system needs, okay? So is that the best way to do it? I don't know. It's the best way to run multiple main runs and multiple manifolds? Could be, right? So it's up to you guys, but you need to take these into consideration as you're doing your design and say what is going to be the best benefit for the current application I'm working on, okay? Because I've had some where I've done some remodels. I went in and they had 5 gazillion pumps on the system, and I come to find out they have one pump that does one loop, and that one loop was like 100 feet long. Like, why in the hell do you have a pump on a 100-foot loop, right? That thing is just rocketing through that piece of tubing and coming back, and guess what the homeowner is complaining about? The house is just never really heated right. Just always feels weird. Sometimes it's really hot, sometimes it's cold, okay? And I got to figure out how to show some pictures because it was ridiculous. It was a maze of stuff.
I used to sub, I don't know if I could cover this later, but is there like an ideal like temperature differential for your like supply and return?
Yep. Okay, and we will get into that in week. Let's look at that. Kind of 2 and 3 it looks like. So next week and the week after, yeah, we will get into.
You might
more
touch
depth.
up on it today too on the heat count.
Yeah. As we go, yes, we better hurry. Get moving, huh? Okay. As we get into the heat loss, we kind of go over that a little bit too, because yeah, your flow rate is going to be a huge dependent on your system, and then who knows what delta T is? Heard of delta T? Who can tell us what it is?
Oh, so the temperature change to take it from the incoming temperature to what you're desiring. That
Close.
It's a difference,
Okay.
yes.
It is the difference, but it's just the difference between your supply out and your return coming back. Okay, that's your delta T of a system. Okay, generally on a radiant system in a house or a building, you will design that for 10 to 20 degree difference, right? So we're going to send 100 degrees out. We want 90, 80 degrees coming back, and that will tell us we have a decent output of temperature going into that room or that area. Okay. Now on snowmelt, can we change that? Can we change that down? Would you think it'd be smaller or greater on a snowmelt system?
We slightly greater.
It'd be greater, right? Okay. You're outside. You're not looking for comfort. You're just looking to get rid of that snow. So generally on a snowmelt system, you go 30, 40 degree delta T of going out and coming back. Because we don't care. We just want it to melt, right? Wasted energy. But it's great. Love snowmelt. Okay? All right. Couple more things real quick on equipment. So boilers, expansion tanks. Okay, we're going to go over all of the purposes of these. Hopefully some of our reps that are going to come in, they'll show you their specific boiler. We'll get a little bit more in depth on that specific boiler so you can learn it and see it, figure out. We're going to talk about controls a little bit. Okay, we do have controls as the last, I think it's the last week. I think it was, but again, controls gets a little difficult. It seems like guys, especially if you're a plumber, they get scared of wires for some reason. I don't understand it. They'll play with pipe all day and sewage and whatever and go jump in the sewer puddle, but they don't want to touch a wire. Okay.
James, I still get scared of wires, man.
Yeah. That's the easy part. Okay. So, but in the next course that we run, course 2, we're going to get a lot more in depth of wiring. Okay. So we'll start getting into different controls and relays and things you can do. I mean, I'm working on a house right now that I think so far I've put probably 50 relays in trying to get this thing to work right because I'm trying to do so many different things. Okay. And I just picked up another 20 today to hopefully finish it. So yeah, it's crazy. All right. Okay. Glycol. Do we do glycol versus water? Okay. What's better? Depends on what they want, right? If it's a vacation home, you better do glycol.
Heat transfer wise, water is better. But
what's the benefit of glycol?
Well, when it's your boys are good at with some freeze.
Okay, that's the only benefit of glycol is you get freeze protection. Okay, that's really the only benefit you get. Some of the other benefit you get is depending on the brand you use, and we try not to narc on anybody, but there's some glycols that are better than others. Okay, so don't always buy the cheapest glycol because it's not really going to benefit you with the radiant system. Okay. So, and that's another point we're going to really get into depth on water quality too, because that's a big issue with our boilers today is water quality. So your water quality is killing your boiler, and I don't know what would air quality.
Hard water. Yeah. And some boiler manufacturers recommend certain glycols too.
True. Yeah.
In the INO manual. So look in your boiler manual.